Here we have the homepage of our Business Analytics Final Project website. Providing a little bit of background on what business analytics is essentially using big data to make better business decisions for the future. There are three levels of business analytics, broken down into descriptive, predictive, and prescriptive. Descriptive analytics can be described as using past data, diving into data queries, reports, visualizations, and data mining. Secondly, we have predictive analytics, using past data to predict the probability of a certain outcome. Lastly, we have prescriptive analytics, which helps form the best plan of action through optimization models and decision analysis. Business analytics is so important in today's society because of constant technology advancements and the ever-rising popularity of social media. These trends produce massive amounts of data called big data that can be utilized to help businesses further understand their customers. Due to the large quantities of data, business analytics is used to organize, interpret, and visualize the data to help maximize business revenue. The goal is to make better business decisions. There are three types of important business decisions and can be broken down into strategic, tactical, and operational. Strategic decisions are the overall direction that the company is heading in the future. Tactical decisions are how the company will achieve these goals in order to get there safely and what resources are needed to be done to do this. And operational decisions involve how the company runs from day to day. The overall purpose of this website is to display the projects that the team has worked on throughout the semester. Moving forward to our projects, our first project that we have here is a data visualization for our digital dashboard. We designed a dashboard for a company called Mobile Gadget Gurus using the Excel Power Pivot. The company is a distributor that sells mobile devices to retailers all over the country, and we made this dashboard to help the operations manager track daily operations of the business. We broke it down into three data sets from 2015 showing customers, products, and sales reps. Here we have our homepage that we thought shows the most important visualizations that can really capture the operations manager's eye. Moving on to the customer data set. Here we have customers by total cost, total sales by customer city, and customer contribution to profit. Moving on to product. We have unit price by product, and you can see how that fluctuates via each product. You can see that Garmin is the highest priced product, and iPod Shuffle is one of the lowest. And then total product sales percentages by month, broken down into each item. And lastly, sales rep. You can see that total profit by sales rep. You can see that Kylie Stanton was the overall lead sales rep, bringing in the most profit. And you can also see that sales reps best and worst customers. You can see that Quessalon is easily the worst customer, as well as the station. For our next project, we created a time series analysis and forecasting model. The forecast that we created was for a refrigerator sales manufacturer for U.S. Midwestern home appliances. We first created a time series plot to determine which of the three forecasting models we should use. On the first linear regression here, we have a simple moving average. Next, we have a regression analysis. And lastly, a double exponential smoothing model. Eventually, we chose the best model and we created an equation to predict the forecast for the next week. Here we have the final linear regression.
Next, we have multiple linear regression analysis, and a linear regression model with more than one independent variable is called a multiple linear regression model, and it helps us predict the unknown y value. So for this model, we used Excel to create a one-way and two-way tables to evaluate the profits for Walsboro Extended Stay Hotel at different prices and rooms rented. Next, we did data mining, which is also known as cluster analysis. And a cluster analysis is a way to divide data into mutually exclusive groups known as cluster IDs, so that the observations in each groups are close and different groups are far. We analyzed the big organics data set in SAS Visual Analytics to create this cluster analysis. After creating the cluster matrix, it was clear that cluster 3 showed the group that has many patients that died the youngest, as well as those that were heavy smokers. Next, we did data mining, and To do this, we use Excel Miner on Excel to create a model to predict which new customer the credit union will approve for credit using their credit score, home ownership, credit history, revolving balance, and revolving utilization. We categorized the data into training, validation, and test sets. We then created a lift chart, ROC chart, and decline lift chart and tested them. Next, we did optimization case, and we developed a model using Excel to help Entunes Devices Inc. to maximize their customers' reach with a budget of $12,000 per week of promotion. Entunes Devices sells electronic devices in-store and online. It is looking to find a best budget allocation on websites to maximize reach of customers. So we used the solver add-in on Excel to help create this model. Then we created a sensitivity report to display the percentages of customers reached for the amount of money spent. And this suggested that our recommended budget would be between $20,000 and $24,000. So that shows that here. And next we did the Monte Carlo risk simulation, and we created a risk analysis model for a new product development at LibCor Pharmaceuticals, and we are helping the company decide whether they want to go forward with a new drug. We created a what-if analysis, then performed a Monte Carlo risk simulation using 10,000 trials.
For our final project, our group has chosen to focus in on logistic regression using SAS Visual Analytics. Logistic regression is a variation of linear regression and is the appropriate regression analysis to conduct when the dependent variable is binary and categorical. Logistic regression is used to describe data and to explain the relationship between one dependent binary variable and one or more metric independent variables. Like all regression analyses, the logistic regression is a predictive analysis. Its purpose is to predict the probability that the output variable will fall into a category based on the values of the independent or predictor variables. This probability is used to classify an observation into a category. When selecting the model for the logistic regression analysis, important consideration is model fit. Adding independent variables to a logistic regression model will always increase its statistical validity because it will always explain a bit more variance of the log odds. However, adding more and more variables to the model makes it inefficient and overfitting occurs. Next, we will provide an in-depth analysis of a specific logistic regression problem that we completed during the semester.
First, we created a box plot that showed the last gift amount and age of those who donated and did not donate to the Paralyzed Veterans Administration. We constructed the logistic regression model using donation as a response variable and added the various continuous effects. It is also important to remember to select information missingness and use variable selection under the Properties tab. After visualizing and constructing the model, a correlation matrix was run to assess for multilinearity. House income and house value had a strong correlation of 0.7046, and house income was removed from the model. Many other variables were removed from the model because they were not statistically significant. After removing the insignificant variables, the data was filtered by the 50-second cluster code, which had the highest R-square value of 0.2191. After completing this step, a few more outliers were removed via the residual plot. This left us with our logistic regression equation, which can be located right here. Various assessment charts, such as the misclassification chart, lift chart, and ROC chart, can help us comment on the usefulness of the model. The misclassification chart shows how many observations were correctly and incorrectly classified for each value of the response variable. Our chart, which had a prediction cutoff value of 0.25, revealed that of the 1,035 people who donated, 395 were incorrectly classified. Of the 3,670 people who did not donate, only 654 were incorrectly classified. Our lift chart shows a best lift of 4.6337 on the 5th percentile. The model then moves away from the best lift in the lower percentiles, indicating that it's not the most effective model. The last chart that aids in the evaluation of the effectiveness of the model is the ROC chart. When looking at the ROC chart, it also appears that the logistic model may not be the most accurate. The chart does not have a steep initial curve, and its max separation and KS statistic is 0.4943.
For our last page, we created Analytics in the News. This page is a collection of recent news articles that showcases the significant impact business analytics is having in our society today and the up-and-coming role it will have in all of our futures. Some articles highlighted include analysis on topics such as data analytics with consumer behavior, data analytics with maximizing marketing return on investments, data analytics with preventive value-based care, data analytics used within the North Carolina government, and data analytics used to manage diabetes. That concludes our final presentation. Thank you so much for listening, and thank you to Professor Fowler for a wonderful class. Our team hopes that everyone has an enjoyable winter break. Thank you.